The purpose of this exhibit is to demonstrate 3D scanning at a basic level. The device pictured here is comprised of two cameras and a DLP projector. This is the device that does the 3D scanning. High-end 3D scanners cost tens to hundreds of thousands of dollars. The idea here is to show a method of 3D scanning that can be used with a machine that costs significantly less than the high-end scanners. We chose to scan a human face for this exhibit. Really, we can scan any three-dimensional surface. However, this process only extracts the surface that the cameras can see. The human face provides a great deal of information on just the front surface, which is why we chose to scan them. Also, it provides some fun interaction for Imaginary IT visitors. The scanning process takes approximately 17 seconds, and is done by projecting a series of light and dark horizontal and vertical bars onto the face. An image is taken for each of these bar positions. These images in a series are then used to determine where each bar is in the final image. Here, vertical bar images are visualized from front to back. Each image is thresholded so that everything that is lit up by a light bar is assigned a value of 1 and everything else is 0. These images are then stacked up in a series so that if one was to drill down through a single pixel, that pixel would have a binary code that is unique to the projected bar that contains said pixel. Prior to doing any scanning, the 3D scanning device was calibrated so that the relative 3D positions of each camera were known with respect to the projector and the projected bars. This means the decoding process provides a direct correspondence between the 2D images of the bars and the actual 3D positions of the bars. With the ability to correspond our 2D images with the position of the 3D projected bars, we can now place an object in front of the bars. This is where the 3D surface extraction happens. When an object is placed in front of the projected bars of light from a fixed camera position, that bar appears to shift in a direction. As the object moves further away from the plane, the projected bars are displaced more. The shift in bar position is calculated for each pixel and translated into a physical shift in space using the calibrated position of each projected bar. This yields a dense 3D point cloud of the object being scanned. Once scanned, the 3D point cloud is then processed into a 3D surface. Here is the original 3D point cloud. Each point in the point cloud is then connected to all of its neighboring points. This gives us a mesh to work with. The mesh is then facetized to generate a three-dimensional surface. This three-dimensional surface can be brought into a 3D animation environment, which allows for mapping of images onto the 3D surface. Here, the face of the visitor is mapped onto their scanned 3D face. We then thought it would be fun to take the visitor's 3D face and place them into an environment that could be rendered as a short 3D animation. Here is the short 3D animation. The Imaginary IT visitor will receive a URL they can take home with them, with which they can download their 3D animated face and share it with friends and family. Thanks for listening, and we hope to see you at Exhibit 117 on May 1st at Imaginary IT.